Okay, so these last few ones, like I said, are a little bit more of a challenge. Not so much A, so I'll review how to do A like we did back in the previous unit, but B and C we're not going to be able to do the way we do A, so these two would be like the extra credit ones. Okay, so over here we have 27 and 81. So if we go back to our Unit 5 or Unit 4 with common bases, I want to know what base these two have in common. They both have a base of 3. So this is 3 cubed is 27, and 3 to the 4th is 81. So here I would multiply this exponent by the exponent that's already there, and 4 by 4x plus 1. So we saw that when the bases are the same, we can actually just cancel them out and set exponents equal. So distribute this exponent, and we get 9x plus 15. And distribute this exponent, and we get 16x plus 4. And now we just solve for x. So we subtract 9x from both sides. $15 equals 16 minus 9 is 7x plus 4. Add 4 to this side, or sorry, subtract 4. Get 11 equals 7x. And then dividing both sides by 7, we get that this is 11/7. Okay, not the nicest fraction, nicest decimal, but that's what we end up getting here. But if you notice on this side, 3 and 4, they're not going to have a common base between them, because those are already in lowest terms. I mean, this one we can write as 2 squared, but that's still not the same as this one. And then over here, 3 and 5, not going to be able to write it with the same base. So what we're going to do for these is take the log with one of the bases. And I recommend taking the log with the smaller base. It really doesn't matter. But if you take it with the smaller base, then you're going to get a number bigger than 1, which is a little easier to deal with than a number less than 1. But either way, you're still going to get a fraction. So we're going to exponentiate, or sorry, log both sides with the base of 3. So log with the base of 3. So here, when I take log base 3 of 3x, these cancel each other out. And I'm left with x here. And over here, log base 3 of 4, well, that really doesn't have an answer. Well, not an answer that I can get off the top of my head. So I just leave it as log base 3 of 4 to the x plus 1. Now, what my properties tell me, my power property, says that if I have an exponent inside of the log, I can take that exponent and I can multiply it to the front. So I'm going to have x equals x plus 1 times log base 3 of 4. Now this is just a number. So here, this one you are going to need calculators. So if I pull up the calculator for this one, these are all going to be ugly decimals. So you're just going to have to carry that decimal through. So here, log base 3 of 4 is that decimal. So I'm going to need that one. So what I'm going to do is I'm going to take that decimal and distribute it inside the parentheses here. So I'm going to get x equals, when I distribute it to x here, I'm going to get that number is 1.26 stuff with an x on it, plus when I distribute it to 1, is just 1.26 stuff with no x on it. Okay, so now I just solve for x like any other thing. So I want to get x's to one side. So I'm going to take this number and I'm going to subtract it from the 1x over here. So 1 minus 1.26 stuff over here. So in the calculator, I'm going to do 1 minus. I can go up and just highlight that. And it's going to give me the whole decimal. And I get that number. So here, this side is going to end up with negative 0.26 stuff. X equals 1.26 stuff. So now just to solve for x, I divide by the number in front, which is the negative 0.26 stuff. And I know it looks ugly, but you're going to have decimals all along the way. So you don't have to write all the decimals. You don't even have to round here. Just leave it in the calculator and just go up and highlight as you need to. So here, for this answer, we need to take this 1.26 number and divide it by this negative 0.26. And we get this one. And then since this is the end, we can go ahead and round it to the 3 decimals that we need to. So it's going to be negative 4.818 is going to round to 19 for this one. So again, not the very best answer. If you don't want the decimals, you can actually leave it as logs. So you can leave this as log base 3 of 4x plus log base 3 of 4. Then you can subtract that from this side. Then you can just type it in the calculator all at once. Either way. I get the decimals along the way because I can go up and highlight it. But if you can't do this, it might be easier just for you to keep the logs. Okay, and then C is pretty much the same thing. So when we solve C, again, it doesn't matter which side you take the log, the base of. I recommend always taking it for the smaller one, but I mean, that's just a preference. You can take it with whatever base you want. So here, I'm going to take it with log base 3. And that's because this number is going to be more than 1, because the base is smaller than the base of the log is smaller than the base of the exponential. If you do it the other way, you're just going to end up with a number that's less than 1, which either way we still need calculators. So, so this side cancels out. So we're going to have log base 3 of 5 to the x minus 3 equals 2x plus 1. And since we have this in the exponent, we can take it and move it in front to make it x minus 3 times log base 3 of 5 equals 2x minus 1, or plus 1. So again, remember, this is just a number. So you're going to find this number, and we're going to take it, and we're just going to distribute and combine like terms as if it was any other number. But it's just going to be a decimal. So log base 3 of 5 is this decimal. So I'm going to take this number and distribute it to the x. So when I distribute it to x here, I just get this number. So 1.46 stuff with an x. When I take it and I distribute it to minus 3, I just take this decimal and multiply it by 3. So 3 times that number is going to give me 4.39. Now here I'm just writing 2 decimals, but I know in the calculator it's more than 2 decimals. don't round it yet. Okay, you use the entire number in the calculator. Okay, so I'm going to take this 1.46 and subtract it from 2 over here. So I get negative 4.39 equals, I'm going to do 2 minus, I got to go up and highlight it, so it's the 1.461, and get that decimal, 0.5, what is it, 3x plus 1, and I take 1 and I subtract it from this side. So I need the 4 number. Oh, actually I need it to be negative first. So negative, go up and get that 4 number. Minus 1. Gives us negative 5.39 stuff. Equals 0.53 stuff with an x. So the last step would just be to divide that 0.53 number. Alright, so I need the negative 5.39, this number, divided by, I need to go up and get that 0.53. And now I can round to 2 decimals, so negative 10.08, that 3 is going to round to 4. And that's why you have to be careful. You have to carry that decimal all along the way, because if you don't, at the very end, oops, sorry, why did I write it like that? That should be an 8, not a 3. If you don't keep the decimal all along the way, this very last step, you're not going to have the right decimal number to round to. It's going to round the wrong way. So let me just go up and check this one. So negative 10.08. Oh, look. It's 3, 4. Okay, so that one rounded it. So I need this one. Actually, is just going to be it's going to stay 3. It's not going to round up to 4. Because this one already rounded it, so this one actually rounded it. I had ended up rounding it twice. I rounded it here and then here. But if I highlight that number, I'll see that it's going to stay at 4, or at 3, because this is a 4. Okay, so those are solving when the base is not the same. The very last example is a different method here. Alright, so here we're still trying to solve for x, but taking the log right now is not going to work because we can't combine these because they're adding exponentials, and we can't really combine it with this constant term. We're going to use something that's in calculus called U substitution. And you're going to use this in calculus when you use the chain rule. So before we start substituting, we're going to rewrite this stuff. So we can rewrite 4x to the 4th, or e to the 4x as e to the 2x squared. So 2 times 2 is the 4, and then the x stays. Plus 7, and here we have another e to the 2x. And minus 18 equals 0. So what we're going to do is we're going to take this e to the 2x and substitute that for u. So for this stuff, we're going to make this a u, and for this stuff, we're going to make this a u. So this is u squared plus 7u minus 18 equals 0. Now this will make it a lot easier to solve, because this one we know how to do. It's a quadratic with no number in front. So we're going to use basic to solve this one. So what are the numbers that are the factors of negative 18 that are going to give me 7? So 18 is 1 and 18, 2 and 9, 3 and 6. We need the bigger ones to be positive, so these are your negative ones to get negative 18. So which one gives me 7? X, or u in this case, minus 2, u minus 9. Okay, so now at this point, I know to solve for x, or solve for u, I need to set both of them equal to 0 and solve. But I can go ahead and put u back in as e to the 2x minus 2 here for this side. And there, sorry, minus 2. And then for this side, e to the 2x. So for u, I'm going to do e to the 2x minus 9 equals 0. So now I can solve for x. So I add 2, 2 equals e to the 2x. So now, in order for me to solve this one, I need to write it in log form, or I need to take the natural log of both sides. So I'm going to take natural log of e and natural log of 2. So remember, natural log has a base of e, so this just cancels out. So natural log of 2 equals 2x. So in the calculator, I'm going to get this decimal, and then just divide that answer by 2. So let's go ahead and get that calculator out. So I'm going to do natural log, so control ln. Oh, let me clear all this. So natural log of 2. There's that decimal, and then I'm going to divide it by 2. So this part is negative, no, not negative, 0.346 is going to round to 7 because of the 5. So 7. Okay, and then on the other side we do the same thing. Oh man. Oh wait, never mind. This one should be a plus 9. So lucky I haven't solved it yet. This is a plus 9, sorry. So here we're going to minus 9 from both sides. So we get e to the 2x equal to negative 9. And to get rid of base e, we take the natural log of both sides. So this is going to cancel out. So I end up with 2x equals the natural log of negative 9. So right here I would do the same thing, get this number and then divide it by 2. But remember about logs. If I try to take the natural log of negative 9, it's going to say error, not real answer, because you cannot take the log of a negative number. So this one doesn't have a solution to it. So this part has no solution. So this is the only answer to the problem. So this one, and it's actually not going to have extraneous, because exponentials can have positives and negatives. This one just happens to not give you an answer. Sometimes both of them give you an answer. This time only this side gave you an answer. Right, so nothing like that you're going to have to do, but I just wanted you to see an example of what you might see later on in pre-calc calculus with still factoring, but using the substitution to factor first. Just use substitution. Okay, so that's the end, and we are done with logs and everything for Algebra 2.